All right. So here we go. The first question from exam for the review was a solubility question. And in the title here, I put which section it's from and the name of the section so that if you need to go back and study that section, then you can do that a little bit more easily. Is barium sulfate soluble or insoluble in water? You can put your answer in the chat box, soluble or insoluble, and then we'll go over it. Yes, it is insoluble. Let me change to a less intimidating color. I don't like to do red all the time. Okay. So I know there is insoluble with a question mark, so let's make sure we remove that question mark. We've got two ions. We've got this barium ion and the sulfate ion. The solubility rules state that anything with a sulfate is going to be soluble except, and then there's a list of these different ions, and barium is one of those exceptions. So it is a sulfate, which means it's, you would think soluble, but since barium is an exception, it is insoluble. So does everyone understand how to use that solubility table? And you'll get this information on the exam. I'm not going to make you memorize it. Okay. Next question was from Dilutions of Solutions. If 25 milliliters of a 0.8 molar potassium chloride solution is diluted to a final volume of 100 milliliters, the new concentration is blank. And you had to fill in that blank. You had to do the math and fill it in. If you have your answers with you or your scratch sheet of paper, you can put what your answer is. You can also just put what equation you used to figure it out. Okay. So the answer should be 0.2 molar. Here's why. Molarity, which is that big capital M, is equal to moles per liter. The volumes that you were given were in milliliters. So you can't just use that straight up. You have to convert these volumes from milliliters to liters. And then you use C1 V1 is equal to C2 V2. So our initial concentration and volume, we have 0.8 molar and 25 milliliters. 25 milliliters is the same thing as 0.025 liters. We did conversions a while back, so you'll need to watch for that. Then we have a final volume of 100 milliliters. That's the same as 0.1 liters. And the question is asking for the new concentration. What we're solving for, I circle it, and then I rearrange. And when you put all of those numbers in, you should get 0.2 molar. So watch for these dilution questions. Make sure that if you're talking about molarity, that you also have liters. Questions on that? If you're good, you can say you're good. If you have a question, you can ask it. Okay. So make sure, again, liters. Don't let that trip you up. What I'm hoping to do is not just give you the answers, but to give you tips on how to take multiple choice exams. Multiple choice exams are sometimes harder than short answer because there's no partial credit. So if you misread the question, then you can get it wrong even if you know the answer to the question. Now we're moving on to a question about electrolytes and non-electrolytes. This is another math question. An intravenous replacement solution contains 4 milliequivalents per liter of calcium ions. How many grams of calcium are in 3 liters of the solution? If you have your answers, you can chime in and let me know whether you got A, B, C, D, or E. I agree. I got A as well. If anybody needs me to go over the math for that, you can raise your hand. Otherwise, I'll just write it in because I'm going to post this as a PDF for those who were not able to make it to the live lesson. And I don't want it to just be like, well, there's the answer. Good luck. So I'll just quickly write it down. And I'm glad that you guys are able to get these. I'm pretty confident you'll see a question like this on the exam as well. Even if it's not one where you have to complete the math, but you have to understand the relationship between equivalence and charge and how many moles. And I am squeezing myself out of room. Okay. Great. Another dilutions of solutions question. During the process of diluting a solution to a lower concentration, which one of these, A, B, C, D, or E, completes the blank correctly? Okay, we had someone say A. Ooh, we're all over the place with this one. Okay, let's go through these one by one. When you're diluting a solution, what that means is that you're adding water in this case. Water is your solvent. If we're adding water, then that means that the amount of solvent is going to increase when you are diluting a solution. We didn't do anything to the solute. So the solute should be the same. Now let's read through these. The volume of the solution does not change. That's not true because we're adding more solvent, so it can't be that. Water is removed from the concentrated solution. That doesn't even make any sense. When you're diluting something, you're adding water. Rule it out. The amount of solute does not change. That sounds like a keeper, but let's keep going. There's more solute in the concentrated solution. That's not true either. The amount of solute is the same in the dilution and the concentrated solution. The difference is the solvent. So that one is a tricky one. The amount of solvent does not change. That's not true. It does change because we're adding more solvent. So we get rid of that one. That means we are left with C. So the process that I use there, before I read all of these different options, I write out what I know about a dilution. That way, I don't get tripped up by the terminology, and I can make sure to rule out the things that I know are not true and improve my chances of choosing the correct answer. Questions, comments, concerns? If you're good, you can say you're good. You have a question, you can ask away. Okay. So remember to use that process when you're doing these multiple choice questions. 1 mole of sodium chloride, a strong electrolyte, is added to 1 kilogram of water. The freezing point of the solution will be, and you fill in the blank, higher than, lower than, same as the freezing point of pure water. So which one is it? A, B, or C? Yeah, you guys are on it. Lower than. When you're adding a strong electrolyte, you are adding some kind of solute to that water. Your freezing point is going to decrease. And since we're talking about freezing point, we should also just mention boiling point. So your freezing point will decrease if you add salt. What about the boiling point? Will it be higher, lower, or the same as pure water? Yes, it'll be higher. So get those two straight in your head. The freezing point is depressed. The boiling point is elevated. If you remember one, just remember the other is the opposite. So another properties of solutions question, which again, you will have something about freezing point, boiling point, and you will have something about hemolysis, crenation, isotonic, hypotonic, hypertonic solution. So make sure that you know, you can go on and chime in with your answer. Make sure that you know those terms and you remember the percentages for sodium chloride and glucose. Yeah, so everybody's getting it right. C, water. Hemolysis. What is that? What happens to a red blood cell when it undergoes hemolysis? Right. It's going to swell and burst. The word lysis actually means to burst, you know? So if you can remember that, remember some of those word tips, that'll help you with the exam. But you'll absolutely have a question like this on the exam. Make sure that you know it. Here's one from dissociation of weak acids and bases. Which one of the following is the strongest acid? A, B, C, or D? I agree. Why? How did you decide that A is the answer? D, you got it right. So the stronger the acid, so the larger the Ka, that's the dissociation constant. That means you have a stronger acid. So what you're looking for in the lineup charadiant is the largest number. The largest number, so if you're just looking at the exponent, it's going to be something times 10 to the minus 4. And then you look at 7.2 versus 2. So this one, 7.2 times 10 to the minus 4, is the largest Ka out of the bunch. Does that help? If it asked for the weakest acid, then the answer would be C, because you'd want the smallest Ka. Your Ka, your Ka is equal to the products of dissociation the concentration of those products. So it would be your hydronium and your conjugate base over the concentration of your acid. And what we're looking for is something that has a really big numerator. That's the concept behind it. If you dissociate a lot, then you're a strong acid because you're making a lot of hydronium ions and conjugate base. Okay. Are we good to move on? Okay. Here's one on the pH scale. Which of the following statements correctly describes the hydronium hydroxide balance in the given solution? Is it A, B, C, or D? I agree. It's B. Now, the way I would go about this problem is before I even looked at all of the choices, A, B, C, or D, I would write out what I know. So let's fill that in. For an acid, which one's going to be greater? The hydronium or the hydroxide? You can just put H plus or OH minus for which one is going to have a higher concentration for an acid. Right. If that's what it is for an acid, then the opposite has got to be true for a base. So acids, that means that you're dissociating and making hydronium ions. Since you're making more hydronium than you are hydroxide. That's just the definition of an acid. You're making hydronium. With a base, it's the opposite. You're not making very much hydronium. You're making hydroxide. and these concentrations are equal for a neutral solution, like pure water. Other questions? Let me know if you're good or if you have another question. Alrighty. A patient with alkalosis has a blood pH of 7.6. What is the hydronium concentration of her blood plasma? I got E as well. So there are two ways to do this. One way where you don't have to do any math, and the other way where you do math. I'll show you both. Alkalosis, blood pH of 7.6, that means that we have something that is basic. Another way to describe a basic solution is to say that's a concentration of hydronium, which remember, we're talking about hydronium, not hydroxide. It is going to be less than 1.0 times 10 to the minus 7 molar. That's just one of the few different ways that we were able to describe acidic and basic solutions. So we talked about them in terms of pH, where if you're below 7, you're acidic, above 7, you're basic, 7 is neutral. We talked about the concentrations of hydronium and hydroxide with relation to the Kw, the constant for water. If you know this, the 1.0 times 10 to the minus 7, it needs to be less than that. The only one that fits the bill and isn't negative, because pH isn't negative, so we can get rid of that one. The only one that fits the bill is E. So you don't even have to pick up a calculator. If, however, you don't remember the concentration of hydronium and hydroxide needing to be less than this or more than that, the other way that you can do it is to use the equation. And that will give you 2.5 times 10 to the minus 8. Does everyone understand both ways of how I solved that problem? Good. I'm always a fan of using logic and common sense before I pull out a calculator, because the calculator can lead you astray. Here's the final question on the review. It's from the buffer section. Which solution has the lowest pH? There's a lot of words here, but what was your answer? A, B, C, D, or E? Good. So the concept here, we're talking about the ratio of acid to conjugate base. When you increase that ratio, you're going to decrease the pH of your buffer. So that's the concept this is testing. Are there any questions about that? That was all 10 of the questions that we did. Like I said, there's definitely going to be a question about dialysis on the exam. And just because it wasn't covered on the practice exam doesn't mean that it won't be covered on the exam. The practice was only 10 questions, and it was there to help you see some of the different ways that the material can be asked. So between the homework and the practice exam, hopefully you've seen a lot of different ways that questions can be asked about what we've learned. If you have any other questions for me about the exam itself, about the final exam, mastering chemistry, this is the time to do it. So even if it's when is everything due or anything like that, you can ask. No, I cannot post another practice exam with more questions. I can tell you that your exam will be about 25 questions plus a couple of bonus questions. So this practice exam was about half the length of what your real exam is going to be. You're welcome. Please make sure you're doing that mastering chemistry. It's due May 6th. I tried to give you as much time as possible because I know it's the end of the semester and you've got all the finals, all the final exams and reports and projects. So hopefully that will give you a little bit more breathing room. Does anyone have any other questions? Questions about the final? Yes. Mhm. Yes. You're welcome. Yeah, the final is May 6th from 3:30 to 5:30, so that's on a Wednesday from 3:30 to 5:30. So this is our last official class. I was going to put out a question to you guys to see if you wanted to try to have some kind of a review before the final exam. I would advise it. I can tell you that there will be probably 80 some odd questions for the exam, the final exam, somewhere between 80 and 85, plus some bonus questions. So it's a long one. Um, we can definitely do that. So I will have to ask Dr. Gravely if I can put out a practice exam for the final for, let's see, so likely not. There will likely not be a grading curve. Um, I will ask Dr. Gravely about doing another practice exam for extra credit on the towards the final. So I can't guarantee that we can do that, but I will ask her. She wants to make sure that if I do it, if we do it in one section, we do it in all the sections. So I'll see if I can work on that with her. But we can do a session on the Tuesday before. I know it's finals week, so people may have finals during this time. But I still have office hours too from 12:30 to 2:30. So if we could all agree on a time, maybe an hour inside of that office hours, I'll send an email about it and do it and set up a poll or a survey on Blackboard for everyone to answer, and we can figure it out. So look for that. I'll either post that tonight or tomorrow morning, but we'll figure it out for a time on Tuesday. Is that fair? Okay. Yeah, I don't want to leave you guys high and dry. That would be incredibly rude. and it's a lot of material. So definitely start reviewing. There are the key dynamic modules on mastering chemistry. Those are extra credit, so you can gain some more points if you lost some points with the homework and quizzes, and it'll help you study the stuff that we did like the beginning of the semester. So if you're having trouble with conversions, there's one on conversions. There's stuff on stoichiometry. There's all types of topics. So make sure that you use those to your advantage as well. Earn some extra points while you study. If you don't have any other questions, that's all I have for you today. So you can always email me. Oh, how many questions on the exam? On Thursday, there will be about 25 questions plus a couple of bonus questions. In the final exam, there's going to be somewhere between 80 and 85. You're welcome. Yeah, so if you have questions, ask. Otherwise, we're done.